we're going to look at reaction energy profiles, and they're just graphs of reactions. We call it a graph of the reaction coordinate, which is kind of a weird way to say what they are. But what we are trying to graph is the energy versus essentially kind of like the progression of the reaction, but we call it the reaction coordinate. So in these, you always have a line on the left that represents reactants and a line on the right that represents products. There are two options. So you can either have a low reactant line and a high product line, or you can have a high reactant line and a low product line. These are typically connected with a curve that goes just above the highest line, whatever it is. And this may look familiar to you because this is a topic that is typically taught in high school chemistry even. And in some courses, it's taught in General Chemistry 1. So this is our reaction coordinate. It's going from reactants to products. And this curved line means something. So I'm going to add in some dotted lines here and a dotted line going over here. I'm going to do the same thing here, straight out from my lines. Now, back in Gen Chem 2, we talked about delta H. We talked about how you can get the enthalpy of the reaction. So the delta H you get from that distance. In both cases, it's the distance between the products and the reactants. It's always that same distance. And then the other thing is that you can tell whether or not it's positive or negative. So if you are starting low energy and you're ending high energy, that means that you have to put energy in. So this is an endothermic. Energy has to be added, usually in the form of like a hot bath or something like that. In this case, you're starting high and ending low in energy. And so that's going to be negative, and that's exothermic. Now, we have something that we're really going to focus on, and it's this section right here. This is the activation energy, and we use EA to represent activation energy. So it turns out that reactants and products can't just run into each other. They can't just be like, boom, we got it. They both have to have gotten enough speed so they run into each other, and that is enough that they knock each other apart and then reform, or something has to have enough energy in that collision to make something happen. There's plenty of times where things run into each other and they just bounce off and keep going. So it has to have enough energy that, boom, something actually happened with that. That's the activation energy, that extra energy to get the reaction going, that extra oomph. And that's the reaction energy profile.